Everything on a satellite sensitive. And the bottom line is this: anytime that you have a satellite that's hit by space debris, it's bad. The outcome's never going to be positive.
Welcome to another episode of Eyes on Earth. We're a podcast that focuses on our ever-changing planet and on the people here at Eros and across the world who use remote sensing to monitor and study the well-being of Earth. I'm your host, Steve Young. We've brought back our buddy Doug Daniels as our guest this week to continue our conversation on Satellites 101. Doug, again, is a principal systems engineer with the Aerospace Corporation at Eros. He also co-chairs the 2019 NASA USGS Sustainable Land Imaging Architecture Study Team for USGS. That group has been tasked with recommending how future Landsat missions should look and what they should be able to do. Well, we spent the last podcast talking about the basics of satellites, how big they are, how much they weigh, how high they fly. Now we want to talk about potential dangers that satellites could face when they're orbiting the Earth. Welcome back, Doug.
Thanks. Good to be back with you.
I've read that there's an estimated 128 million pieces of debris smaller than 1 centimeter in space as of January 2019. 900,000 pieces of debris from 1 to 10 centimeters and more than 34,000 pieces that are larger than 10 centimeters. Where in the heck did all that junk come from?
Yeah, it's unbelievable, isn't it? And sadly, all that junk came from us. All that junk came from spacefaring nations that over the years have deposited broken, used up equipment, spent rocket stages, old satellites, or other artificial man-made debris. This is a tough topic for me because I've spent my whole career working in space systems and taking advantage of the kinds of things that we can do for space. And it's really unfortunate that the race to space and the value that we've gotten from these capabilities over the past decades has really come at the price of polluting this otherwise pristine environment. Today, the United States Air Force tracks tens of thousands of artificial objects that, as you were talking about, you went through some of those numbers, and we're talking about tens of thousands of objects that are 10 centimeters or larger, and those are the ones that we basically can detect, and there's estimated to be a whole lot more that are smaller.
So for a satellite system like Landsat, how big of a concern is space debris?
Space debris is something that the teams, the flight operations teams, the mission managers, the flight managers, they worry about on a daily basis. Avoiding any type of collision with an on-orbit spacecraft or another satellite or a piece of space debris, it's paramount to ensuring that doesn't happen. Not only would a collision with another object likely be mission ending, it would also further pollute that environment that we're talking about. That space debris all comes from somewhere, and collisions are one of those things that's really detrimental.
You're able to track debris at a certain size. Again, what size is that, and how are they able to track that kind of stuff?
As I mentioned, the U.S. Air Force is the one that predominantly tracks most of the debris that's in orbit around the planet. The kind of rough order of magnitude, if you will, of the size of object is 10 centimeters and bigger is where we are today. There's other capabilities that are being put in place. One's called the space fence, which would have the ability to detect objects that are much smaller. Make us space operators aware of many numerous objects that are smaller than 10 centimeters out there. But knowing precisely where those are, what their orbital trajectories are, is important.
Do satellites ever get hit by space debris and survive it? Is there any way to know that?
So, oddly, the answer to your question is yes. Satellites can be hit by space debris, and it does happen. But when we're talking about a satellite getting hit by a piece of debris and surviving it, we're talking about something really small, like a paint fleck. The types of closing speeds are really extraordinary. And it'd be like getting hit by a bullet, or even, in some cases, even faster. One of the examples that sticks in my mind is the European Space Agency has a satellite called Sentinel-1A. That satellite solar array got impacted by a tiny piece of space debris, and it actually punched a hole through the solar array, created a divot in the solar array panel. Now, how do we know that? Well, we know that because the performance of the solar array dropped. And also, it's cool. They had a little camera that shoots down the solar ray so they can actually see a before and after picture and see the damage that was done. If you consider the particle that likely impacted the solar ray was less than a millimeter in size, so really tiny, the impact area was roughly 100 times that.
Really? How much does it take to hurt a satellite? I mean, I'm guessing from what you're telling me, a fleck is enough to do significant damage to a satellite.
It depends on where the satellite is hit. But the bottom line is this. Anytime that you have a satellite that's hit by space debris, it's bad. The outcome's never going to be a positive. So it doesn't take much. Really, in the case of the example that I just went through, we're talking the size of a microparticle or a paint fleck. So everything on a satellite is sensitive. The electronics, the solar rays, the thermal shielding, the instruments, the communication platforms, these are all highly susceptible to even the tiniest bit of debris impact.
So where Landsat's at, are there many satellites in that orbit? And if there are, how do we keep satellites from running into each other?
Where Landsat is in orbit is actually a fairly popular orbital space. As we talked about earlier, it's roughly 705 kilometers in altitude, and it's a sun-synchronous polar orbit. There are numerous satellites that are in that orbit. We share that space with other NASA satellites. We share that space with European satellites. We share that space with Japanese and French platforms, Chinese as well. There's a number of platforms that are in that space. So organizations typically communicate with each other, particularly if the spacing between satellites is on the order of short minutes. And sometimes in the past, there have been accidents.
Accidents meaning satellites running into satellites? Or?
Yeah, believe it or not, unfortunately, yes. Satellites have collided with each other. Perhaps the most famous collision occurred in 2009. There was an Iridium-33 spacecraft that collided with a defunct Russian Cosmos satellite, and they collided at roughly 12 kilometers per second. And that was at an altitude around 780 kilometers above the surface of the Earth, so higher than where Landsat flies. And those satellites created thousands and thousands of little pieces of debris. And there's no easy solution to keeping these kinds of collisions from happening other than space owners and space operators have to be really diligent. They have to carefully monitor, and they have to have the ability to move out of the way. We just saw an example of that where a European satellite and a SpaceX Starlink platform were predicted close approach for collision. The European satellite moved out of the way. And as we populate orbits with more capabilities and more vehicles, we're going to see more of that.
A game of satellite chicken? Is that what we're playing?
Unfortunately, it's funny that you say that, but that's really an interesting way to think about it. And it's pretty accurate. And here's the problem. There's no traffic lights. There's no traffic laws for space. So in that example that I just went through, you have a Starlink, a SpaceX platform that is newly on orbit. You have a European spacecraft that's been there for a while. Who moves out of the way? In this case, SpaceX opted not to move, so the Europeans did. The question about responsibility and diligence is based on an owner-operator perspective. There isn't any laws or traffic cops, if you will, governing those outcomes.
So with so much debris, are we constantly getting out of the way of debris? And I mean, do we have time to get out of the way? Or how do we prepare for something like that?
We do a good job. We, USGS and other civilian space platforms, for example, that are flown by NASA, really do an outstanding job monitoring the orbital debris environment. We have tools that do that. You'd like to have a week or more to say, hey, there's a predicted close approach. We'd like to understand that. We like to get more eyes on it, if you will, as the time of collision approaches. Sometimes we have less than a few hours. It all depends. The environment, especially the environment of a low Earth orbit, like what we talked about in the last podcast, is a little bit volatile. Atmospheric effects sometimes change how objects are orbiting. And so the more frequently you can track something, the more precisely you know its location, the lower your uncertainties are, the better job you can do whether you have to decide to move or not.
So I imagine in my mind these flight operation team members sitting down at a control panel with a joystick, moving it back and forth, moving the satellite up and down. I imagine it doesn't actually happen that way.
No, it doesn't. It's a fun visual, though, right?
Right.
But in reality, no, it doesn't happen like that. If you think about the process, we have orbital dynamics, flight dynamics teams that carefully assess what the environment is like, and they really work hard to determine what the optimal maneuver or burn plan is. Because we're located where we are for a reason. We want to stay there. That's where our mission is. That's the type of track we want to be on. And anytime I move out of the way, it means I'm positioning myself potentially in a location I don't want to be. And reorienting myself and getting back to where I was before is not easily accomplished. So there's a lot of planning that goes into this. What'll happen is a specific burn plan will be developed. Those command sequences will be uploaded to the spacecraft, and they will be executed at precisely the right time. And the burn will likely be for small tenths of a second. So the image of someone maneuvering with a joystick, humans, we don't react as precisely and accurately and quickly as we need to. So it's all done by command loads and executed by flight software.
And again, you mentioned in the earlier podcast that the satellite has hydrazine on it.
It does.
That hydrazine is there specifically to help with maneuvers like this, to burn for a few tenths of a second, get out of the way, and then
basically, more often than not, that fuel will be used as a thrust vector. We'll change our delta velocity at the point in our orbit where it's most optimal to hopefully balance your mission specifications as well as get out of the way. And there's always uncertainties involved. So when you maneuver, you don't want to make situations worse. So again, it's carefully planned, but you're right. That hydrazine is used. It's a little bit of a push, if you will, changes the velocity, adjusts the altitude a tiny bit, and then typically we'll stay there and we'll allow the gravitational pull of the Earth to kind of draw us back over time to where we'd like to be, assuming we can afford to do that.
You know, one of the things I've wondered is, does the gravity not eventually pull it all into the atmosphere to burn up or not?
It does, actually. It just takes a lot of time. So there's a lot of factors that are involved in how long it takes for a piece of debris to reach the Earth's atmosphere and essentially burn up. The lower an object is, the more drag there is, so the quicker it's pulled down. The object's ballistic coefficient, in other words, how it's shaped. Is it really aerodynamic, or is it a booster that's kind of got a broad side to it? All are factors. But it takes years, Steve. It takes years for something to essentially get pulled down and burn up. And in a lot of cases, greater than our lifetimes. So we're talking of in excess of 100 to 150 years for things in low Earth orbit to naturally decay.
Has there ever been a conversation about sending robotic satellites up to clean up space debris? I mean, is that too science fiction-y, or is that...
Absolutely not. It's not far-fetched. There's a lot of organizations that are giving a lot of thought to how to clean up the space environment. And those will all basically be robotic in nature. They're only far-fetched in the way that there's no good way to go about it in terms of a cost-effective way to collect a lot of debris. Space is still really a big place. So it's not like, your neighborhood garbage truck driving down the street and, making 10 stops in the span of a couple blocks. The types of distances we're talking about are substantial. So it's not easily done.
So I guess my last question, Doug, is could there ever be a time when the space debris just gets to be too much?
Some speculate that we're already on our way to too much. It's interesting. There's a well-known theory. It's called the Kessler effect, or maybe you've heard it called the Kessler syndrome. There was a NASA scientist. His name was Donald Kessler. And in 1978, he contrived of a scenario where the density of objects in low Earth orbit would be such that they would collide. And collisions would create more debris, and that debris would collide and create more debris, and essentially have this escalating factor of a debris-filled low Earth orbit such that it would become unusable. Think about that, where there would be so much debris where we couldn't fly satellites like Landsat, or people couldn't leave the planet because flying a human astronaut through low Earth orbit would be too dangerous. So we obviously never want to get there. And being responsible in space, understanding how debris is created, tracking space debris, responsibly operating vehicles, moving out of the way, avoiding collisions. Your very first question is, where did all this junk come from? Well, hey, it came from us. So we need to do some work about understanding what that means. I mentioned earlier SpaceX and Blue Origin. One of the reasons why I like what they're doing, I like where they're pushing technology, is because instead of leaving those rocket boosters in orbit, they're bringing them back down. They're landing them as they can, and then they're reusing them. So just think, over the course of a year, there might be 10 or 12 or 15 less boosters. And then in 10 years, there's 150 or 200 less boosters. And none of them collide with anything. With it seems small, but over time makes a difference. And that's what we need to do more of.
We've been talking to Doug Daniels. He's a principal systems engineer with the Aerospace Corporation out here at Aeros, and he's enlightened us over several shows on the basics of satellites, how they work, and today on the issue of maneuvering around space junk. Thanks again for joining us, Doug.
You're welcome. Thank you.
We hope you come back for the next episode of Eyes on Earth. This podcast is a product of the U.S. Geological Survey, Department of the Interior. Thanks for joining us.